algebra students. Mr. Lawrence here, and I'm apologizing for not being able to be available today. I actually spent some time in the hospital between the last time I saw you and now. I will be coming to conferences tonight. I'm on some medicine that makes me a little bit tired, and so I'm taking the day off as a sick day, but I am coming into conferences. So if you have a conference scheduled with me, please don't tell your parents that I won't be there, because I will. Okay, I just won't be in school today, and obviously there won't be an algebra party today. All right, we're going to get on with a little lesson here. Hopefully you watched the video from Monday night, but we're going to review it, and then you're going to get a chance to practice some of this, so I'll try to keep it pretty quick. Remember first that we're working with absolute value, and the definition of absolute value is the distance from 0 on a number line. The distance, that doesn't look like the word distance, sorry guys. The distance from 0. By the way, your notes should be out while you're watching this video, and if you already took notes last night, that's great. Just have them out in front of you. Maybe you'll catch something you didn't catch the first time. And if you didn't take notes over the day break, then you go ahead and take them now, because you're going to need them to help you do these problems. These problems are not cake problems. They're not intuitive. Very few of you will be able to just figure them out by looking at them. I'd be surprised if anybody could with the true absolute value inequalities. Anyway, the definition of absolute value is the distance from 0 on a number line. And that's important because when we look at the absolute value of x, it equals 9. Well, we're asking what number is 9 spaces away from 0 on a number line. A lot of you want to go, oh, Mr. Lawrence, that's too easy, it's 9. The problem is you're not considering that it's also negative 9. There's two solutions. X could equal 9 or negative 9. By the way, if you run into equals problems on the test, you'll do them like an or. Notice my answer had an or in it. Okay, so if you run into equals problems in class, they will be done like an or problem. All right, remember the little trick for these two types of problems. You're going to see either a less than or probably a less than or equal to, like that, a greater than or a greater than or equal to. And remember, I intentionally mispronounce this. These are the less thans. So when you see a less than, it's an and problem. And these are the great or problems. So the greater than are great ors. So we have less thans and great ors. All right, so how do we do that? Well, we come on down here to the absolute value of 4. Excuse me, x plus 4 is greater than or equal to 3. Well, this is an or problem, so I'm going to do x plus 4 is greater than or equal to 3, or x plus 4 is less than or equal to negative 3. I cannot write an or as one sentence. I like to write my ands that way, but ors it doesn't work. I do my little algebra, listen to Saddam to get the x alone, and I will get x is greater than or equal to negative 1. I'll show negative 1 on my number line, and I need a closed point there, and I need the values greater than negative 1. Well, they would be to the right of negative 1. Okay. Now, if I have to solve this part over here, I'm still going to subtract 4 from both sides, and I will end up with x is less than or equal to negative 7. So I show negative 7 on my number line, and that would be a closed point, and the number is less than negative 7, like negative 10 is less than or equal to negative 7, right? Negative 10 would be to the left of negative 7, and there we go. And remember, generally speaking, the picture for ors will always look like this. Remember, we held our thumbs going outward? Okay, so there's the first example. All right, here comes your second example. I see it's a less than problem, so here's how I like to do the less thans. I go 3x plus 4 is less than 8, but instead of writing and then a whole nother sentence, I just write this. Negative 8 is less than 3x plus 4. It works out to be the same way. If you want to write it as two parts, I won't give you a hard time about it. I'm just telling you this is how I like to do it. Now, I work to get this x alone, this variable alone. First thing I'm going to do is subtract 4, but I'm going to do it in 3 places. And when I do that, I'm going to end up with negative 12, which is less than 3x, which needs to be less than positive 4. X is not alone, so I'm going to divide by 3 in 3 places. And I'm going to end up with negative 4 is less than x, which is less than, and I'm going to go ahead and put 1 and 1/3, because I'm going to a number line, and I don't know that 4/3 makes as much sense to me as 1 and 1/3. So I'll put negative 4 on, I will put 1 and 1/3 on. I know they're both going to be open points. Now, I need my x values to be in between those two. So, my picture will show the x values being in between. I'm going to shade everything in between. And if I wanted to test it, I could pick any number in here, say like 0, plug it in. 3 times 0 plus 4, well, that's going to be 4. And the absolute value of 4 less than 8, is that a true statement? It sure is. But if I picked a number outside the shaded region, say like 5, well, I would get 3 times 5 is 15. 15 plus 4 is 19. Is the absolute value of 19 less than 8? I don't think so. The absolute value of 19 is 19, which is not less than 8. All right, these are actually really easy. You just have to remember that there's two parts to them. Okay, scrolling down to problem number 3 here. It looks like it's an OR problem, so I'm going to write it as 9 minus x, which is greater than or equal to 13, or, and I'm going to have 9 minus x is less than or equal to negative 13, and remember, I cannot write these as one statement. All right, so I'll solve this left one. I'll subtract by 9 on both sides, and when I do that, I get negative x greater than or equal to 4. I have to multiply or divide by negative 1, whoop, 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 which means x will become less than or equal to negative 4. All right, I got to solve the other part. I'm going to subtract 9, just like I did on the first one. And I'm going to get negative x is less than or equal to negative 22. And then I'm going to divide by negative 1, divide by negative 1, and then x will be whoop, 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 greater than or equal to 22. The two important numbers I have to show on my number line are negative 4 and a positive 22. Looks like I'm going to have closed points on both of them. And I need x to be less than negative 4. Well, negative 5 is less than negative 4, and negative 5 is to the left. Then I need numbers greater than 22, like 30, which would be to the right of 22. And there you go. Now, by the way, if you plug in a number like 30 in here, well, 9 minus 30 would equal negative 21. The absolute value of negative 21 would equal 21, and that is greater than or equal to 13. So you see it works. If I plugged in negative 5, I would get 9 minus negative 5, which is the same as 9 plus 5, which is the same as absolute value of 14, which equals 14, and that is greater than or equal to 13, so it checks over here. And then likewise, if I pick a number in between, say like 0, why did I pick 0? Because the math is easy. 9 minus 0 is the same as the absolute value of 9, which is 9. It's greater than or equal to 13. I don't think so. And notice there's no shading in here. All right, that's it for the lesson today. Remember, I will be at conferences tonight. Going to take today off, get some rest, and hopefully be back Thursday to help you folks out. All right, Mr. Lawrence signing off. If you need to watch this video again, have the sub replay it. If you're ready to go get to the homework, that's okay too. Good morning, everybody.